Welcome back to the Stories of Northern Life podcast, brought to you by the Sault Ste. Marie Museum. I'm your host, Nicole, and today we're going to be talking about landforms, so all about the geographical region here in Sault Ste. Marie. So let's get into it. Now, first off, when we are looking at landforms, we're going to be looking at the Canadian Shield. Sault Ste. Marie sits on the edge of the Canadian Shield, also called the Precambrian Shield, the Great Shield of Canada, or the Laurentian Plateau. This crust is known as the North American Craton. A craton is the stable portion of the continental crust. It extends from Greenland to northern Mexico. The shield is the exposed portion of the craton. The Canadian Shield is 8 million square kilometers and makes up 50% of Canada's landmass. The Canadian Shield is one of the largest continental shields. It is shaped like a horseshoe or an ancient warrior shield, hence the name the Canadian Shield. It extends from Newfoundland and Labrador through Quebec down to Kingston and into New York, across to Gravenhurst or Parry Sound, around Georgian Bay, all the way to Sault Ste. Marie, then up around Lake Superior. Then it extends into northwestern Michigan and northern Wisconsin and even Minnesota, to the southeastern corner of Manitoba, and it cuts diagonally across through Saskatchewan to the northeastern corner of Alberta, and then up into the Northwest Territories, Nunavut, and the Arctic archipelago. Now let's look at its formation. It took 3 billion years for the Canadian Shield to be formed as a result of several forces. The tectonic process caused different parts of the Earth to collide and form huge mountain ranges that used to cover the Canadian Shield. This mountain range was known as the Grenville Mountain Range and was said to be as tall as the Himalayas. They were eroded mostly by glacial activity. So could you imagine an ice sheet or just an ice block, huge, being able to topple mountains? And so this area is now low hills and plains. Parts of the Canadian Shield date to the Precambrian Eon, which is the earliest part of Earth's history and makes up about 80% of the geological timeline. As the continents were moving around and colliding together, they formed Pangaea, the supercontinent. During the late Paleozoic and early Mesozoic eras, the supercontinent began to break up during the Jurassic period, finally forming the continental structure we know today during the early Cenozoic era. After all these continental shifts, the shield was not done forming. The next series of formations came in the way of erosion, namely the glacial activity. So, let's look at glacier activity. There have been 5 recorded ice ages over the 4.6 billion years of Earth's history. So first off, we have the Huronian Ice Age, which was about 2.4 to 2.1 billion years ago. Then we have the Cryogenian Ice Age, which was about 850 to 635 million years ago. The Andean Saharan Ice Age, which was 460 to 430 million years ago. Then the late Paleozoic, Ice Age, which was 360 to 260 million years ago. And finally, the latest, the Quaternary Ice Age. It was about 2.6 million years ago, all the way to present day. Humans emerged 2.3 million years ago. That means for the entirety of human history has taken place during the Ice Age. Now, during an ice age, the Earth goes through the cold periods, known as the glacial periods, and hot periods, known as interglacial periods. When the Earth is not in an ice age, that means there is no ice on the Earth at all, meaning there's no glaciers at either of the poles. The last glacial period, when the Laurentide ice sheet advanced across Canada and the northern United States, that was between around 95,000 years ago and 20,000 years ago, roundabouts. The ice sheet covered more than 13 million square kilometers, and the thickness reached 3 kilometers or more. Between around 11,700 years ago and 9,000 years ago, the ice began to melt and recede. The Laurentide ice sheet was a massive ice sheet or continental glacier that covered most of Canada and northern United States. Since it was formed, Earth has gone through several glacial and interglacial periods, meaning that the ice sheets had advanced and retreated over the land several times, toppling mountains and smoothing out the landscape. The Laurentide ice sheet spread out west from the Hudson's Bay and east to Labrador. It not only smoothed down the topography, but polished and leveled rock surfaces, scattered debris irregularly, and disorganized the drainage system. So that's where we get the lakes and rivers forming. The northeastern part of the Canadian Shield is tilted, and that's in northern Labrador and Baffin Island. And there, the land rises more than 1,500 meters above sea level. During these cool glacial periods, snow and ice would build up during the cold winter months, but the summer months did not provide enough heat for the ice to melt. Therefore, it would just continually build and build and build, and then that's how we get the glaciers. Scientists have found that during ice ages, temperatures would average around 7.8 degrees Celsius, with the polar regions being 14 degrees Celsius cooler. During the periods of deglaciation, when the Earth would warm up and the ice would retreat, scientists discovered that orbital changes of the Earth caused higher sunlight levels to reach the Earth. They also found that there were higher levels of carbon dioxide in the atmosphere that caused higher temperatures, allowing the ice to melt. So the scientists were actually able to take core samples of the glaciers and were able to track all the different layers of the ice, and that would be the different years. And so that's how they tracked the CO2 levels. And if you think with today's CO2 levels being higher, it could possibly be an issue. So, glacial periods occur every 11,000 years, and ice ages occur every 100,000 years. So we are once again in this period where there are higher sunlight levels reaching the Earth and higher CO2 levels. However, this process is being worsened by pollution, which is causing even higher levels of carbon dioxide. And so that's increasing the temperatures and melting the glaciers. Now, let's look at the landscape. 95% of Canada's landmass has been covered and shaped by ancient ice sheets. The advancing and retreating of the ice sheets flattened out the Grenville mountain range and removed the layers of soil covering the craton and exposing the Precambrian rocks underneath. The exposed portion is now known as the Canadian Shield. It was during the last ice age that the ice sheet gouged out the Great Lakes, and once the ice retreated, it filled up the lakes, and that's how our lakes were formed. There is a thin layer of soil covering the Canadian Shield, and this has been a barrier to settlement. Agriculture has been difficult on the Shield, and farming is only really possible in small basins and valleys. Now, there are 4 types of forests on the Canadian Shield. First off, we have the boreal forest, then the mixed forest, the boreal forest / tundra, and then the tundra. The largest of these forest regions is the boreal forest, which is the largest forest region in Canada. It is composed predominantly of white spruce, black spruce, balsam fir, jack pine, white birch, trembling aspen, tamarack, and willow. The boreal forest is found around the world, and Canada has the largest portion of this forest at 28%, or 552 hectares. The world's boreal zone is often called circumpolar because it circles the North Pole, just south of the Arctic Circle. Countries in the boreal zone include Canada, the United States, Norway, Sweden, Russia, China, and a few others. Worldwide, the boreal zone covers 1.9 billion hectares, or 14% of Earth's land, and makes up 33% of Earth's forested area. Most of the trees in this forest are relatively young compared with many that grow in the more temperate climates. It is regularly affected by forest fires, insects, and other natural disturbances that help to continually renew itself. These natural disturbances removed aged trees from the forest, expose the land to sunlight again, and allow the next group of trees to germinate and grow into a new forest, and release nutrients from the trees. When trees are harvested by foresters, they must plant new trees or seeds to sustain the forest. Other forest regions on the Canadian Shield is the Great Lakes St. Lawrence Forest. It is south of the boreal forest, giving it a warmer climate. The predominant trees here are red pine, eastern white pine, eastern hemlock, yellow birch, maple, and oak. The warmer weather allows the hardwoods to grow. So hardwoods are also more of your deciduous trees, meaning the trees that have leaves, so they're going to change color in the fall and the trees will lose their leaves. Then you also have the coniferous trees, which are more of your evergreens. So they're ones that have the needles and they're pretty much going to stay green all year long. So that's sort of the difference between hardwoods, and then your coniferous trees are going to be a little bit more of your softwoods, but that's really generalized. But at least that gives you a little bit of the ideas about the trees. So the tundra is covered in snow for half the year, There is only a very short growing season, and the tundra typically gets less than 25 centimeters of precipitation. Therefore, it is considered a desert. Most of the tundra's soil is permafrost, meaning it is permanently frozen. The southern regions of the tundra have a thin layer of topsoil that is not frozen during the summer months, allowing for some plant life to grow. The region is largely treeless or considered a non-forested area. Instead, it is covered in shrubs, grass, moss, sedges, and lichen. Much of the Canadian Shield is covered in coniferous trees that make the soil more acidic, meaning agriculture is difficult at times. You want the soil to have a more neutral pH so that your plants are able to grow. The soil is often coarser and well drained, so you're not going to be able to have a lot of extra moisture for your plants to pull from. As the glaciers wore down the topography, the weaker rocks were eroded. This left many rivers and lakes across the shield, some of them quite large. Ontario and Quebec alone have over 12,000 lakes that are larger than 3 kilometers squared, and there are countless small lakes. There are also many marshes and bogs on the Canadian Shield, and the lakes that are here tend to be more acidic and highly oligotropic, meaning they are low in nutrients. So it's a little bit harder for sea life or marine life to grow there. So it's a little bit harder for the fish. Waterways were the main source of travel as the area is covered in a dense forest. So that's how we have a lot of the voyageurs traveling through and going by canoe on the Great Lakes. These waterways are still used for the transportations of goods from east to west and vice versa, just as the voyageurs and fur traders of old used. The landscape of the Canadian Shield has inspired many artists throughout history, such as Paul Kane, William Armstrong, and even the Group of Seven. The area may not be good for farming, however, it yields great resources including mining, lumber, forestry, and hydroelectricity. Lastly, we have geology. The Canadian Shield is made up of Precambrian rock. So Precambrian rock is some of the oldest rock on Earth. Radiometric or radioisotope dating indicates that it is made up of rocks that range from 1.8 to 4 billion years old. In northwest Quebec, rocks date to 4.28 billion years. It is currently the oldest known rocks in the world. Due to the age of these rocks, the fossils that are found here are mainly algae and ocean water dwellers. Metamorphic rocks are the main type of rock that is found on the Canadian Shield. So metamorphic rocks come from the metamorphosis, meaning change. They change form, structure, or substance. This type of rock has gone through a lot of stress and pressure. As the glaciers were moving across the land, they were crushing the rocks and fusing them together. Large expanses of granite are found on the shield from this metamorphosis. Granitic rocks are normally composed of quartz, feldspar, and mica. They are the remains of the ancient mountains. The shield is made up of relatively flat expanses of metamorphic and associated igneous rocks. The region is composed of ancient crystalline rocks. Any rocks composed entirely of crystallized minerals without glassy matter. This attests to a long history of uplift, depression, mountain range formation, or orogeny and erosion. This supports the view that Earth was a dynamic planet throughout most of its history. Shield rocks are very resistant and strong. Therefore, the weaker rocks were eroded and deposited either on the shield as the ice melted or were pushed south below the shield. The shield is one of the most mineral-rich areas in the world. It hosts nickel, gold, silver, and copper. Some minerals found in northern Ontario include hematite, magnetite, jasper, and white quartz. Iron, gold, goethite, pyrite, and siderite from the Helen mine north of Wawa. Amethyst, whose color is composed by iron inclusions, is the official mineral of Ontario. Thunder Bay has the most abundant source of amethyst in Ontario. Amethyst is found with pyrite, galena, calcite, fluorite, native silver, and many more. In northern Ontario, there is a clay belt and vein of gold. Banded iron formations occur abundantly around Lake Superior. They compose the main sources of iron in North America. Many towns in northern Ontario are either mining or logging towns. When Francis Hector Clerc came to Sault Ste. Marie, he bought a nickel mine to support his steel plant. He used iron ore that was mined around Lake Superior. And one last thing I would like to leave you off with is one of sort of my favorite stones, which is pudding stone. And it is local only to this region. The most abundant area being St. Joseph Island. And pudding stone is a conglomerate, and I sort of always like to explain it to people, especially the kids coming in with all the school groups, is you can think of pudding stone kind of like when you're making cookies. So if you look at pudding stone, most of it is largely composed of the lighter rock. So if you think of that as your cookie dough, that's more of your softer rock. So that's going to be the one that is easily molded by the glaciers being pushed around, and as it's going across the landscape, you also are picking up other little rocks as well. And you can think of the other rocks kind of as your other ingredients. So they're a little bit harder. So you have maybe your chocolate chips, your nuts, or other things that you'll want to put in your cookies. And that's how you get the pudding stone. Now, there are a whole bunch of different conglomerates all over the world, but the unique combination of all those different rocks is unique to this region, and one of them being red jasper. So when you look at pudding stone, you'll see that there's sort of a unique red stone in there, and that's the red jasper, and that is how we get pudding stone. You can come into the museum and see all different types of these geological samples that we have up in our skylight gallery. Come in, take a look at it, and you can even stop in our gift shop where you can purchase some of these rocks that were found by our assistant curator, Rick, who goes out along Lake Superior, collects the rocks, and tumbles them and polishes them for us. So it's a unique souvenir you can take home with you. I hope you enjoyed today's episode. So, thanks for listening. Bye.
Did you know you can get unlimited admission to the Sault Ste. Marie Museum for a whole year for just $15? Yep, that's right, and there's more perks to that too. Go to Sault Museum, that's SAULT, museum.ca, under Visit, and learn more about our membership options. And if you're a business, corporate or nonprofit, we have plans for you too. Reach out to us by emailing info@saultmuseum.ca with any inquiries.
Hi, I'm J.L. Fizzell, and I write and publish poetry inspired by nature and the art of being human. These are some of my words. This poem is from my third book, North of Dreams, and it's about mountain climbing. And for any of you who have done that, you'll be able to relate. Mountain climber. Maybe the mountains call to me. Maybe they feel like home because I'm used to challenge and adversity. I'm used to jumping hurdles and holding on for dear life. Maybe the mountain feels like home because despite all of this, I still see the beauty of rocky terrains and the reward of reaching the peak. The moment you're certain you could fly. I hope this poem took you somewhere inside yourself that you needed to go. You can listen to my story here on the Stories of Northern Life podcast. Links are in the show notes.